All right, just in case you refuse to read for comprehension because it's way too long, I'll do one example real quick that probably is not on that sheet, but that's okay. So let's have a lawnmower. I'm not very good at drawing lawnmowers. Okay. Kind of my wife likes with the big wheels so she can rear them up and drop them down on something. And let's have someone pushing that lawnmower straight down the handle. And, okay, so they're pushing on it. And I'm going to have this lawnmower, let's say they're just moving at a nice constant speed, constant velocity, to the right. Constant velocity this way. They're not pulling on it, in other words. Whoops, drew their foot backwards in there. Okay. If I want a free body diagram of the lawnmower, I need to label this angle here of the handle. I'll give it data. Okay, so a free body diagram, first thing you do is sort of isolate the thing you're talking about, which is the lawnmower. You draw a set of coordinate axes that will line up with the motion of the object. So this object's moving across horizontally, so we're going to line our axis up horizontally. That way we only have possibly one acceleration anywhere. If you line your axis up differently than that, you may have an acceleration on both axes and the math gets terribly complicated. Okay, and then let's call this the x-axis and this the y-axis, or you could say horizontal and vertical. Then you draw a dot to represent the lawnmower. Okay, that's what that dot represents. And now you start looking at all the forces that act on that lawnmower. Now, when we draw forces, I want you to start off getting in the habit of labeling them. You don't have to write out all the words. You can abbreviate it, but I want you to name the force, what it's acting on, and where it's coming from, because all forces, they're, technically they're a push or pull, but there is no such thing as an isolated force out in space. Forces are always an interaction between two objects. So the easiest one to think about is gravity, the earth pulling down. So we'll say the force, gravity. Now you will see some teachers, if you do a Google search, they'll use W for weight because the force of gravity is the weight. I don't like that. It's force of gravity on the mower. So I'm going to make sure I want to use the symbol M. Yeah, why not? Yeah. So on the mower by the earth. So the earth is pulling down on the mower, straight down towards the center of the earth. We'll talk about that more later. The person is actually pushing down the handle. So we have to, I didn't say how much, so it's sort of arbitrary. So I'm going to put it down here. Most of the time we call that force from a person an applied force on mower by person. Force applied on mower by person. And this angle would be theta. Okay, I haven't talked about it yet, but if something is moving at constant velocity, Newton's first law says that the forces have to balance in every direction. So we know this thing is not falling through the earth, so there must be a force straight up on it. We call that the normal force. Normal meaning perpendicular, not normal as in everyday, average, whatever, or the normal thing to do or something like that. It has nothing to do with that. Normal in math means perpendicular. So this force is perpendicular to the surfaces in contact. And it always pushes. I mean, this force normal is not going to pull down on a lawnmower. The ground pushes up on it. Now, how long do I need to make that? Don't know yet. I need to think a little bit more about this situation. I need to look at all the forces. There has to be a force this way, or it would be accelerating to the right. Well, there's going to be some friction or drag or something on that thing, probably more friction than anything. So I'm going to call this the force of friction on the mower by the ground and the grass and everything else touching it. Now, Think about anything else. If you list any other forces, you have to be able to list the agent that is interacting with it. Like you can't just throw a force in here to the right and say force applied on mower. You'd have to say force applied on mower by something. And you notice there's nothing else. There's the guy, there's the ground, earth. That's it. That's all there is. So these are the only four forces. So to move at constant velocity, I need the forces left and right to balance. So I need this part right here of this force, this component of the applied force to balance this. And I'll show that I meant to make them the same length by just drawing slash lines. I need this normal force to balance this piece of the applied force and the force of gravity. So it needs to be like pretty long. So this is the force normal on the mower by the ground. This force of gravity and this part of the push from the guy, the part that's pushing down on the handle, downward, balance the normal force. Okay, and I'll try to show you that with some instruments later. So that's what a free body diagram looks like. Okay, you should have axis with dash lines. You should have arrows that represent, and they should be solid arrows, representing the forces. And they should start on the object and go away from it. So what you probably see is he's pushing this away. So you would think, well, why didn't you make it here? On the AP exam, you always start the force vectors on the object pointing away from it. Okay, so that's a free body diagram for that lawnmower. Hopefully that'll help you. Now, later we'll use these free body diagrams to figure out things like how big is this normal force? How much friction is there? And so forth. Okay.